Alright, welcome back everybody. In this video we're going to look at the examples from the improper integrals, integrands with infinite discontinuities lesson. Our first consideration in these is going to be to consider the integrand and where it has an infinite discontinuity. And so let's take a look at the first example. Determine if the integral from 0 to 3 of 1 over the square root of 3 minus x dx converges or diverges. If it converges, find its value. So our first consideration is, where does this integrand have an infinite discontinuity? And that happens at 3, where it makes the denominator equal to 0. And so in order to find this integral, we're going to in fact take the limit as b approaches 3 from the left of the integral from 0 to b of 1 over the square root of 3 minus x dx. Okay, and so we'll now go ahead and find the antiderivative. And the antiderivative of 1 over the square root of 3 minus x is negative 2 square root of 3 minus x. And we're going to evaluate that from 0 to b. So we've got the limit as b approaches 3 from the left of negative 2 square root of 3 minus b minus negative 2 square root of 3 minus 0. And now we find this limit as b approaches 3 from the left. So, 2.998, 2.999, etc., etc. Well, as b approaches 3 from the left, this term just approaches 0. And so the limit of this is going to be equal to 2 square root of 3. And so this integral converges, and it converges to 2 square root of 3. Alright, on to example 2. Determine if the integral from negative 2 to 3 of 1 over x to the third dx converges or diverges. If it converges, find its value. Our first consideration is, where does this integrand have an infinite discontinuity? And it has an infinite discontinuity at 0. So we need to split this integral up into the integral from negative 2 to 0 of the function, plus the integral from 0 to 3 of the function. Now, in order for this to converge, we need both of these integrals to converge. And now we're going to establish limits. We'll take the limit as b approaches 0 from the left, since we're approaching on the negative side in this first integral. And we want the limit as a approaches 0 from the right, since we're on the positive side of it in this integral. And now I just need to go ahead and find the antiderivative of this function. And the antiderivative of x to the negative 3 is going to be negative 1/2 x to the negative 2, or negative 1 over 2x to the second. And we're going to evaluate that, from negative 2 to b. And then we're going to evaluate this other integral. Equal to 3. Alright, now, let's see, that gives us the limit as b goes to 0 from the right, of negative 1 over 2b squared minus negative 1 over 2x squared and the second integral is the limit as a goes to 0 from the right of negative 1 over 18 plus 1 over 2a squared. Now, As b approaches 0 from the left, this term approaches an infinite value that goes to infinity. Therefore, this integral diverges. Alright, last one, example 3. Determine if the integral from 0 to infinity of 1 over x squared dx converges or diverges. If it converges, find its value. Our location of concern here is 0, so we're going to turn this into the limit as a approaches 0 from the right, since the rest of the integral is to the right of that. The integral from a to infinity of 1 over x squared dx. Okay, and so I will integrate from here, and the integral of 1 over x squared is negative 1 over x. Ooh, I forgot about the limit approaching infinity. Alright, you know what? I stopped for a second and didn't realize that that was approaching infinity as my upper limit, and I just charged forward. What I want to do is I want to break this up into two integrals here. Break it up into this one and this one. Alright, now I know that this one converges from our extremely important fact that we learned in the last lesson. And so since I know that that piece converges, my determination of whether the whole thing converges or diverges falls to the behavior here. And so this is going to be equal to the limit as a goes to 0 from the right of negative 1 over 1 minus negative 1 over a. And as a approaches 0, this approaches infinity. And therefore, this diverges. And since one part of the original integral diverges and the other part converges, that means the whole thing diverges. Alright, that's the end of this video. Hope you get some practice dealing with improper integrals with infinite discontinuities and get this under your belt a little bit more. See you guys next time. Have a great rest of your day.